Dear students, I hope and I am sure that you all know the first element of the periodic table, that is hydrogen. It is the most abundant element and the lightest element known. It was discovered by Henry Cavendish and its name hydrogen was proposed by Lavoisier because when it burns in the presence of oxygen, it produces water. Today, we will discuss the unique position of hydrogen in the periodic table. Now, why its position is unique in the periodic table? We will discuss that in some of its properties, it resembles the alkali metals and it also resembles the halogens. But at the same time, it differs from alkali metals as well as from the halogens. It is the first element, its atomic number is 1, it has 1 proton and 1 electron, and it is the only element which does not have neutrons in its nucleus. Its electronic configuration is 1s1. It resembles both alkali metals and halogens. Therefore, the position of hydrogen is anomalous. It has unique position. Resemblances with alkali metals. Alkali metals are lithium, sodium, potassium, rubidium, cesium and francium. Francium is radioactive. And we will discuss the resemblance of hydrogen with these alkali metals, that is the first group elements. The first point of resemblance is their electronic configuration. Hydrogen, atomic number 1, electronic configuration 1s1. Lithium, atomic number 3, electronic configuration 1s2, 2s1. Sodium, atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. So, we can see that just like alkali metals, hydrogen also has 1 electron in its outermost shell and that is also in the s orbital. Electropositive character. Just like alkali metals, hydrogen can also lose 1 electron readily to form hydrogen ion. Let's see the equation. Hydrogen losing 1 electron and hydrogen ion is formed, which is now a proton. Sodium easily losing its electron, the valence electron, and is converted into sodium ion. Again, these two, that is hydrogen and alkali metals, are resembling each other. Valency and oxidation state. Hydrogen, like alkali metals, also shows oxidation state of +1 in its compounds. Just see the examples. HCl, hydrogen chloride, in which H is in +1 state. Similarly, the alkali metals like sodium and potassium, they both are in the +1 state. Combination with electronegative elements. Hydrogen, like alkali metals, form binary compounds with electronegative elements. Halides. Hydrogen forms hydrogen chloride, sodium forms sodium chloride, potassium forms potassium chloride. Sulfides. Hydrogen forms hydrogen sulfide, sodium is forming sodium sulfide and potassium forms potassium sulfide. Similarly, oxides. Hydrogen forms water with oxygen and sodium and potassium are also form the same type of oxides. Again, we can see that hydrogen is resembling the alkali metals. Liberation at cathode. When the fused salt of alkali metals are electrolyzed, metal ions are liberated at cathode. Hydrogen is also liberated at cathode on electrolysis. Let's see the equations. Molten salt of sodium, that is sodium chloride, on electrolysis produces sodium ions at cathode. Similarly, hydrogen chloride on electrolysis produces hydrogen at cathode. Reducing agent. Just like alkali metals, hydrogen also acts as a strong reducing agent. Iron oxide is reduced to iron using hydrogen. So, we have seen so many points of resemblances between hydrogen and alkali metals, but in some points it also differs from alkali metals. Let us see that. Ionization enthalpy of hydrogen is very high. Just compare the values here. Ionization of hydrogen is 1312 kilojoules per mole, whereas the ionization enthalpy of lithium and sodium are quite low. For lithium it is 520 kilojoules per mole and for sodium it is 495 kilojoules per mole. We can see that the values differs a lot. Non-metallic character of hydrogen, whereas alkali metals are typical metals. We know that hydrogen is a gas and alkali metals are typical metals, that is, they are solid. Atomicity. Hydrogen is diatomic. Two atoms of hydrogen combine covalently and a hydrogen molecule is formed, whereas alkali metals are monoatomic. They also differ from each other. Oxides of the alkali metals are basic. Hydrogen oxide is neutral. Again, they are differing from each other. Nature of compounds. Compounds of hydrogen are predominantly covalent. Compounds of alkali metals are ionic. Let's compare the example. Hydrogen chloride is covalent. It is formed by the sharing of electrons. But NaCl is ionic, that is, the bond is formed by the transfer of electron. Sodium loses one electron and chlorine gains one electron and the bond is ionic in sodium chloride. Now, we will see that how hydrogen resembles halogens. Halogens are the 17th group elements, that is fluorine, chlorine, bromine and iodine. Let us discuss the points of resemblances between halogens and hydrogen. Electronic configuration. Like halogens, hydrogen has one electron less than the nearest noble gas configuration. Now you can see and compare the electronic configuration. Hydrogen electronic configuration 1s1, the nearest noble gas is helium, its electronic configuration is 1s2. So, you can very well see that hydrogen is just one electron less than the nearest noble gas electronic configuration. Fluorine, the halogen, its electronic configuration is 1s2, 2s2, 2p5. Its nearest noble gas is neon. Its electronic configuration is 1s2, 2s2, 2p6. Now, again you can compare fluorine and neon. Fluorine is just one electron less than neon. Similarly, chlorine and argon. Chlorine is also one electron less than argon, the nearest noble gas. Ionization enthalpy. Ionization enthalpy of hydrogen is quite close to that of halogens. Its ionization enthalpy is 1312 kilojoules per mole. The ionization enthalpy of fluorine is 1680 kilojoules per mole, chlorine 1255 kilojoules per mole and bromine 1143 kilojoules per mole. All these values are quite comparable. Electronegative character. Hydrogen also shows tendency to accept electrons to form monovalent anion to acquire noble gas configuration. Just now we have seen the electronic configuration of hydrogen, halogens and noble gases, and we saw that the hydrogen and halogens are just one electron less than the noble gas configuration. So, hydrogen and halogens both have tendency to gain one electron and to enter into the most stable noble gas configuration. Let's see the equations. Hydrogen gaining one electron and becoming hydride ion, and its electronic configuration changes from 1s1 to 1s2, and 1s2 is the electronic configuration of the helium gas, the noble gas. Let's see the case of fluorine. Fluorine is gaining one electron and is changing into fluoride ion, and now its electronic configuration will be that of the neon gas. Oxidation state. Like halogens, hydrogen exhibits oxidation state of -1 in its compounds, sodium hydride and sodium chloride. Now just compare these two compounds. Hydrogen is in -1 state. Similarly, chlorine is also in its -1 state. It is hydride ion, it is chloride ion. Diatomic nature. Hydrogen molecule exists as H2. It is diatomic, just like halogens. Halogen also exists as diatomic molecule F2, Cl2, Br2, I2. And just like halogens, hydrogen is also non-metallic, and all these halogens are also non-metallic. Liberation at anode. When fused alkali metal hydrides like sodium hydride, lithium hydride is electrolyzed, hydrogen is liberated at the anode. Halogens are also liberated at anode when fused alkali metal halides are electrolyzed. Let's see the equations. Molten sodium hydride on electrolysis produces sodium and hydrogen at anode. Sodium chloride molten on electrolysis produces sodium and chlorine at anode. Nature of compounds. Hydrogen, like halogens, combine with non-metals to form covalent compounds. Covalent compound means compounds formed by the sharing of electrons. Hydrogen is combining with carbon, silicon and germanium. Similarly, chlorine is combining with carbon, silicon and germanium, and all these compounds are formed by sharing of electrons. That is, they are all covalent compounds. But as I have told you, it also differs from halogens. Let's see some points of differences between hydrogen and halogens. It has less tendency to form hydrides, that is H negative ion, as compared to halogens which form halide ion very easily and very readily. Absence of unshared pair of electrons. Here you can see that there is no unshared electron on the hydrogen atom. But on the chlorine atoms, there are 3 electron pair each on the chlorine atoms, and only 1 electron is shared. So you can see that the halogens have the unshared electrons, but there is no unshared electron on the hydrogen atom. So now you can very well understand that how hydrogen resembles and differs from the alkali metals, and how it resembles and differs from the halogens. So the question was, what position it must be assigned, with the alkali metals or with the halogens? So it has been assigned a unique position, that is in the center of the periodic table. Although initially it was assigned position just above the lithium with a bit space, but now in the latest periodic table it has been the position assigned is in the center of the periodic table. Now let me give you a quick recapitulation of this topic. Hydrogen. Hydrogen is the first element in the periodic table. It is the lightest element known. It was discovered by Henry Cavendish in 1766. Its name hydrogen was proposed by Lavoisier because it produces water on burning with oxygen. In Greek, hydro means water, gen means producing. Hydrogen is the most abundant element in the universe and the third most abundant on the surface of the globe. Hydrogen has the simplest atomic structure among all the elements around us in nature. In atomic form, it consists of only one proton and one electron. Unique position of hydrogen in the periodic table. Similarities of hydrogen with alkali metals. Electronic configuration of hydrogen 1s1 is similar to the electronic configuration of alkali metals. Hydrogen forms unipositive ions by losing one electron, just like alkali metals. Like alkali metals, hydrogen form oxides, halides and sulfides. Dissimilarities with alkali metals. Hydrogen has very high ionization enthalpy. Hydrogen does not possess metallic character under normal conditions. Resemblance to halogens. Hydrogen can gain one electron to form a negative ion. Hydrogen is short by one electron to the corresponding noble gas configuration, just like halogens. Hydrogen have very high ionization enthalpy which resembles halogens. Like halogens, hydrogen forms diatomic molecule. Dissimilarities with halogens. Reactivity of hydrogen is very low as compared to halogens. Absence of unshared pair of electrons. The oxides of halogens are acidic while hydrogen oxide, that is water, is neutral. Unique behavior of hydrogen. It resembles alkali metals as well as halogens. It is difficult to assign any definite position to it in periodic table. Therefore, hydrogen is best placed separately in periodic table. Initially, the position given to hydrogen was above lithium, that is with the alkali position. You can very well see from the periodic table, hydrogen is just lying above lithium. But now the latest position. The latest position assigned to hydrogen is unique. It is separated from the alkali metals and halogens. It is placed in the center of the periodic table. Dear students, I am sure that the topic is very much clear to you and you can very well understand that why initially to assign the position to the hydrogen was a debatable topic and why now it has been assigned a unique position in the periodic table.